Welcome back. Now we will take a closer look at our Whitewater Solver itself in here. First, make sure that the volume source here is set correctly. If it has this orange color, it always means that the link is fine. If it would be red like this, that means no link. Okay, that's fine. And normally this import volumes into DOPS should be disabled because it can just use the volumes from previous simulation, so you save memory and calculation time. As you can see here, the Whitewater Solver is spread up into different sections. We have the foam, the spray, the bubbles, and some solver settings. Basically, the solver settings are fine. We don't need to change anything here. So let's start with the foam. First of all, we're going to increase the depth of our foam a bit to 0.07. So that just means that the depth of our foam layer is a bit thicker. Next are the lifespan attributes. As it's set up here, it automatically makes sure that the emission attribute will be used as a lifespan. So in areas where we have a high emission, we get also a longer lifespan. And this is then fitted between the minimal and the maximal lifespan, which is also in seconds. So it's between 2 and 4 seconds. If you're doing a scene, for example, a boat driving through a calmer ocean and you want to have all the white water a long time behind the boat, so to have this nice trail, you probably have to increase the lifespan so the foam lives longer. In our case, where we are putting more importance to the spray, we can just leave the lifespan settings as they are. Just make sure to enable the preserve foam function here. That makes sure that in areas we already have a high foam density, the lifespan will be extended even longer, so to keep this foam together floating on the surface. With this minimal and maximum foam density values, you can just tweak the strength of the preserve foam effect. So below the minimal foam density, it will be reduced by the reduction rate here, the lifespan. And between these values, we have a ramp where the preservation rate will increase the lifespan of our foam. So the values here are fine, just make sure that it's enabled. Next, we are going to take a look at the behavior tab. Let's see what values we have here. So these are already more interesting also for the spray, because these values you tweak here, even if it's on the foam tab, they will inherit their effect also on the spray. So I noticed that these values here also have a big impact on the look of our spray. So we will now take a more detailed look at them. The advection strength of our foam basically says how strong the velocity of our fluid will advect our foam. The standard value here is fine. But on these values down here, we're going to make some changes to compress the look of our foam and spray more. As you remember in the reference, when the ship was hitting the wave, we can just take a quick look here. When it's hitting the wave, the foam and the spray stays together, and then after a few seconds it gets vaporized, it spreads up more. And to get this initial advection of these foam parts together, we're going to tweak these values here. Because if you lower the depth scale below 1, you will have something like a surface tension effect, and that's what we're looking for here. So let's lower this value to 0.4, the variance to 0.3, and increase the move amount, so that means that these effects here can move the particles more to the calculated location. If you put a too high value for the move amount, we will cause some snapping, but with 0.4 it should be fine. Also, what we're going to tweak is the depth scale lifetime ramp, because the depth scale influences this attraction effect between the foam particles on the spray particles. So as we saw in the reference, that after a few moments this attraction is less and we even get this vaporizing effect, we're going to lower these depth scale lifetime ramps so that we make sure that this depth scale has less effect over the time. So let's see. On the first point here, we're going to lower it also to a value of 0.95, and the next point we will also lower it quite heavy to 0.6 around here. And we'll add some more points to build a nice curve here, so the effects get less and less over time. Okay, and one last point here, which lowers the effect even more. Let's move just this point a bit more here to have a nicer ramp. Okay, that's looking fine. So that will make sure that in the beginning of the lifespan, the foam and also the spray will stay closer together. Okay, so that's about the foam. Next, on the spray tab, there are less options. Just make sure to activate the drag. It's for the same reason we also lowered the inherited velocity. So even if the particles get a really high initial velocity, the drag will act over time and will make sure that they don't go too crazy. So make sure it's ticked on, but let's lower it to 0.03. Otherwise our particles will have an unnatural behavior, just like they are stuck in the air. Okay, another interesting tab here are the bubbles. I decided for this simulation to disable the bubbles. In many cases it's useful to have them also for the look, because if the bubbles which get generated below the water surface rise, they will transform to foam and you get a nice pattern on our ocean surface. Also, if you have a boat driving through the ocean when it's really calm, you can actually see the bubbles below the surface in the refraction path. But as our sea here is really rough, and as we are putting all the attention to the boat impact and the emitted spray, let's disable the bubbles also for performance reasons, so we have to simulate less particles. Just keep in mind in other cases it might be useful or even necessary for the look to enable the bubbles. Okay, as mentioned, the solver tab here is all fine. So to see an effect of all the changes we made, let's look through our camera here, the render cam. And let's just do a quick flipbook. In the beginning I showed you a flipbook of the untweaked settings, so we will compare it and see if we are already heading in the right direction. To do the flipbook, just do a right click here, flipbook with new settings, and let's put 120 frames here. Make sure it crops the view mask overlay so we save some memory, and hit the accept button. So here we have our finished flipbook. It took a while, but now we can see the results of the tweakings. If you compare this to the first flipbook I showed you with the basic settings, it's already a huge improvement. The spray isn't flying away too fast, and also it clumps more together. The same here for the foam. So the first tweaks were really successful. But one thing we can already see is that there will be spray and perhaps also foam on top of our boat collision. So I think we should modify the collision that also the cabin of our boat here is in the collision, so we make sure that no spray is flying through our cabin here. So let's do this before we go to the next clip and add the custom forces. Jump back up and let's see in our boat here. At the moment we are taking the collision from here, so let's just duplicate these nodes here. And we need to make sure that we get the top part here, so let's duplicate these transform pieces here as well. And also these three nodes to just open a new stream where we will modify the result of this blast node. Just hit the little arrow here so you can reselect the objects you want, and we will just select these parts here, for example also this here, to make sure that these are inside our new collision. Hit the enter key, and now you see that we kept these objects connected here just in the first input of the transform pieces, and now you will see that this boat here is also moving. For sure we also need the movement a bit down, but in this case we don't have to extrude something because the particles are using the actually polygons here, not the VDB volume collision. So let's just connect it to our collision source so that the velocities are fine. Now we have the attribute create 3 as an output here and the VDB1. So let's make sure that we reconnect it inside the DOP network correctly. Jump back inside your Whitewater DOP and let's say here attribute create 3. And here out VDB1, okay, even if it's using the polygons here. So now you can already see that we have this new collision inside our DOPNet, and that will make sure that the particles or the spray which flies up here will collide with our cabin and not go just through it. Okay, that's it about first tweaks for our Whitewater sim. In the next clip we will start adding some custom forces. See you there.